Okay, welcome to the second lecture on data analysis, and in this lecture we will be discussing some basic concepts of statistical methods. This will be an overview of this session. So we will be discussing why we use statistics in analysis, and then what are the different types of statistical data analysis, common types of descriptive statistics, basic concepts, and central tendency. Okay, so in data analysis we use a lot of statistical techniques, and the question is that why we go for statistics, why we don't use some other techniques. So the reason is that in statistics there are a lot of algorithms or techniques for data analysis. So no matter in which research field we want to do research, statistical tools helps us in data analysis. Okay, there is some code from Organ, and that is, whether you are a student, a researcher, or just a citizen interested in understanding the world around you, statistics can offer methods for helping you make sense of your environment. If you want to understand your environment, if you want to understand your data, statistics is the subject that helps you understanding your data. There are two types of statistical data analysis. One is descriptive and the second is inferential. In descriptive statistic, you use the existing data, you just summarize the existing data, you compute the average, you compute the mean, or whatever the mode, median, exactly. And then in inferential statistics, you look at the data, you don't have direct information from this data, but on the base of this data you deduct some information. So you inference information, you use some existing information, and on the base of those existing information you guess some other information. Okay? Yeah.
For those the weather. The white are going in this direction.
Exactly.
So this means
if there are clouds, there will be rain. So this is inferencing. You mean this? If there are clouds, then the chances are there will be rain. Okay, so this is inferencing. This is not generalization, but you inference information from some existing information. So is it clear?
Yes.
Okay. The common types of descriptive statistics are percentage, mean, and standard deviation, etc. So in the coming few slides we will go through these simple concepts. Okay, you already know about percentage. I think it's too easy. Mean, you already know about this. And standard deviation. So standard deviation is, in some set of data we have some mean or median value, and in deviation we want to see that how the data is distributed from this mean value. Okay? Any example? In your class there will be some average age among you, and then some people will be like elder than that mean age, and some will be younger than that mean age. So this is distribution. Okay, so like how the data is scattered around some specific central value. Okay, Then these are some basic concepts and statistical data analysis. One is population. So population is actually the whole set in which we are interested. Okay, if you want to know about the results of upcoming election, so the population will be the whole Pakistani registered voters. Okay, and then sample. So sample is some subset of this whole population. If you want to see the tendency of voters, so in these surveys, some set of data, few sets of data are selected, and then their tendency is studied, and then on the basis of those few data sets, the results are generalized. So one is population and second is sample. Population is the whole set of interest, and sample is a subset of this whole population. So why in these surveys few sets are taken and not the whole population? What's the reason? No. What? Okay. Because what? Yeah, it's too expensive to consider the whole set, and it maybe impossible. If you want to look at the people voting tendency, so you have to conduct the election, a countrywide election, otherwise you cannot do that, and it takes a lot of resources. Okay, and then parameter, an unknown fixed value of population characteristics. So then you define some parameters, some attributes, what you want to study in your survey. Okay, so what can be the example of parameter?
Age, education.
Yes.
Influence.
Yes, exactly. Yes. Okay. So the other term is randomness. Randomness is sometime like the events happens randomly. We cannot detect what we will get from some event. Like when you throw coin, so you don't know on what face what will be the output. So that is randomness. And then variability is like in a coin you have two different outcomes. Okay, and then statistical analysis is that when something happens, you analyze why it happens and how it can happen in future. Okay. And then the next term is central tendency. So the concept of central tendency is that like the accumulation or the outcome of some events, and if these outcomes are spread along some central point, so that is like central tendency. What is the average of some outcome? What is the median of some outcome? What is the mode of some outcome? Okay. So there are three types of central tendency. One is average, one is median, and one is mode. I hope you already know about mean. Is there anyone who doesn't know about mean? What is mean? Average. Okay. Sorry? Exactly. Number of samples Sum of samples divided by number of samples. Sum of samples values divided by number of samples. I use the word sample. Everybody understand what sample means?
Is a subset of population.
Okay. Everybody knows this term sample. Okay. Mean is the most common measure of central tendency. Usually, when we refer to something, we usually take the mean. For example, when we say that the age of class 6 student, okay, then we say that it's usually the students are 11 years old. So we actually refer to the mean value. Yes, percentage, like in context of grading we use percentage, but in day-to-day life we usually use the average value. For example, when a shopkeeper buys shoes from the company, so he brings more average sizes and few outliers. Okay. So the mean value, this is affected by the extreme values. Outliers are extreme values. For example, in your class there will be some average age, and who is the most elder students other than me? I am not your student, but who is the most elder one? No one want to shut okay. Okay. And who is the youngest one? Fakhruddin? Okay. But you seems to have the same age. Huh? Izhar is the youngest one. Okay, so these extreme values, these are called outliers. When you compute mean, so usually this mean value, it is affected by the extreme values. Okay. Yes, we have some example here. What's the mean of these 5 values? Okay. 5? Sure? Okay. 5.5? Yeah. If you want to clear GRE, so you should be a bit faster. 5. Okay. Okay, this is next GRE question. What's the mean?
6.
Who said this? Okay. The rest agrees or no? 15. Huh? Okay. You are in the examination section. Yeah. Okay. Okay, and then median. So median is not the average value, it's not the mean value, it's a straightforward middle value of the samples. So you have to sort the given values and then half values on one side, half values on the other side, and the mid value is considered as the median one. Okay. For example, here we have 5 values, and when you sort these values and then you divide these number of samples by 2, and the middle value is considered as the median value. Okay. So usually the median value, it is not affected by the extreme values. Okay. For example, okay, we have these 5 values. The median is 5. Then we have again 5 values, but the size of these values is different. Here the last value is 14 and here the last value is 9, but in both cases the mean is 5. So the median is not affected by the extreme values. It is just affected by the number of samples and not the size of the number of sample size. This is same, but sample values. Okay. And then the other interesting value is mode. So in mode you consider the whole number of samples and then you count how often a given value has occurred in the given samples. Okay. For example, here we have like 1 is once and 3 is once, 5 is twice and 9 is thrice. Okay, and 12 is twice. So the mode is the value which has occurred most often. Okay. So here we have 9 as mode of the given samples. And here the mode is, there is no mode. There can be more modes and there can be no mode. Okay. Which measure of central tendency should be used? Now the question is that when you have data in front of you, next question is whether mean can represent the data most suitably or the median can represent the data most suitably. Okay. The measure you choose should give you a good indication of the typical score and the sample or population. I think it will be good if we take some example. If I have like 1, 2, 3, 4, 5 and 6. So the mean is how much? 2.5 or more? It should round about 3.5 round about. Okay. Now when I have this final value, what? Okay, so the mean is 1 minute. And if this value is, let's say, 36, then the average will be 8.5. So now in this case, this mean doesn't represent the data well, because for 5 samples the average is 3.5, but we have one extreme value where the value is 36. So if we say that the average is 8.5, then this means that 5 values are below this average value and only one value which is above this average value. So this doesn't represent this data well, because an average, some values should below this average value and some should above, but the number of values shouldn't be that different. Okay, so if we take mean, then this like the situation should be that 50% value should below the mean value, 50% should be above the mean value. In this case, I think the median would be most suitable to represent this data, and then the median value is 3.5. Okay, we have 6 values, so the median value is 3.5. Okay.
So we have the formula n by 2 for given numbers.
Sorry.
So we have the formula of n by 2 for given numbers in the case of
N by 2.
n by 2.
Yes.
So the third number is 3.
We have we have total 6 numbers.
Yes, sir.
Okay, if we consider 3, then like on the left side we have 2 values and on the right side we have 3 values, so that is not the correct mean. But when we consider 3.5, then like the mid of 3 and 4.
So you said that the median should be
Any value? No.
should be.
This is not important that the median should represent some sample value, but it should be mid of the number of samples. If you have 6 samples, then the median will be like 3.5. Okay, so 3.5 will be on the left side and 3.5 will be on the right side. So it's not necessary that the median should represent any sample value. Okay. I already said that mean is sensitive to the extreme values, and we also discussed some examples. So I don't think we need too much. Okay, like here in this example, so the mean is 14.5, and this 14.5 doesn't represent the data well, but the mean can represent this data well. Median is not sensitive to extreme values, and mean is used when you are unable to use the median is used when you are unable to use the mean because of extreme scores. If there are too much extreme scores, so in that case mean is not a suitable choice. Okay. Mode doesn't involve any calculation or ordering of data. You just consider the number of specific values and then the number of occurrences for those specific values. Okay, is it clear?